Right, welcome everyone. We are live already. Cool. So let's get straight to the point. Welcome again to a new episode of Flyte School. This is a kind of monthly or periodic, let's say, live stream where we try to cover content that was a requested by the community or we've seen patterns in the interaction with the community, and we feel that it's important to dedicate a space to dive a little deeper on specific topics. I'm David Espejo, part of the developer relations team at Union AI, who is one of the largest contributors to Flyte. And today we'll be covering the process to deploy Flyte on GCP. Cool. So let me share my screen and we'll kick it off. Cool. Right. So we'll take a brief look. It's kind of a recap on the components or the Flyte architecture components, and also an introduction on how the reference implementation for GCP is structured. Finally, how to use it. And in the process of covering how to use it, we will use it live. So fingers crossed. We'll be uh, covering a bit on how to run workflows, especially workflows that require custom images, and some Q&A at the end. If you have questions, if you're watching us on LinkedIn or YouTube, feel free to drop questions in the chat. I think StreamYard will help us surface this, and we'll try to cover them by the end of the session unless there's something urgent we need to touch right on. Okay, cool. So yeah, let me start with um, mentioning briefly Union, and specifically Union Cloud product. Union is the main sponsor for these sessions, and it's interesting because you bring your compute basically, and this is the Flyte managed version with a number of additional features that are not available in OSS, like role-based access control and task level monitoring of resources, among others. So feel free to check it out. It's a very interesting option to run Flyte or to let a specialized team run Flyte for you. Cool. So a recap on the Flyte architecture. This is straight out from the documentation. There's a section called component architecture. The diagram is not perfect, but it kind of describes what you end up getting, at least at the logical, from a logical point of view, when you deploy Flyte. We don't show here the user plane. In the user plane, you will find the CLI and the UI. And in the control plane, you will find different components. For a deeper dive on the architecture, please check out the a previous Flyte School session where we dedicated entire 60 minutes to cover Flyte architecture. The resources that are marked with a star here are external dependencies for a Flyte deployment, and it's part of what we will cover here today. So we will cover the ingress, the database, blob storage, Kubernetes cluster, and by the end of the session, we will have everything, including Flyte itself, deployed on a GCP environment, hopefully. Cool. So this is the overall idea with the reference implementation. In what we mean by reference implementation is uh, considering learnings from the interactions with the community, Flyte community, who happen to be also GCP users. We try to incorporate this in an automated implementation using Terraform. And when you run these modules, you will end up with an opinionated environment that works works as is described in this diagram. So you will have an ingress resource that is managed by an Nginx controller. That will be your main point of contact from the user perspective, be it the CLI or the EOI. Your first touch point will be the ingress. And then it will connect to the control and data plane services from Flyte. And all of these services run as Kubernetes workloads on a GKE cluster. And for this to properly access GCP resources, we're making use of workload identity as the recommended approach to do this, and cloud IAM roles and service accounts. And that is the same for also for the actual workflow executions. They need to authenticate before they can access, be it cloud storage or blob storage, or before the Flyte control plane can connect or contact or use the database, the relational database. It will need to first get a proper authorization. So this is the overview of these reference implementations. A bunch of decisions have been made beforehand, and that is the case with any other automation, especially for a reference implementation. This means that you can adapt this and extend for your particular environment, but here we're trying to use this as an educational resource. And also to help you bootstrap an environment real quick. Cool. So I'll briefly touch on the modules, but first I want to go to the repo itself. Let me see, deploy Flyte. There you go. So we'll find here Flyte and GCP. And I'll be basically following the instructions here, right? So the summary is that the first thing you need to do is to create a project in GCP and to log in your gcloud CLI session to make sure that session is authenticated and authorized to access all the resources. I already did the first portion, already have a project, Flyte TF8. It's already connected to a Billiken account. And that's all I have. And the next thing you need to have available is a bucket. Simple bucket. The instructions are in the README, but this bucket will be used by Terraform to store state. This is essential for Terraform, and these are the two main things you need to provide to the module: an existing project and a GCS bucket. That's it. Okay, so the next piece is to actually authenticate your session. So I will do this right away. It will trigger an OIDC flow, allowing me to authenticate the session, and there you go. I'm here. It's already recognized my credentials. Cool. So the next piece, according to the instructions, is to go to the locals file. I mean, you need to clone the repo, etc. We'll go right away there. And nope, this one. So locals is where you will define again the particular configuration or particular identity of your environment. So, for example, the application and environment, you can change this. And the modules will use this to build the prefix for the names of the majority of the resources. I won't change this, but what I will change is the project ID. I mean, this is what you will see in the repo. So you need to make sure that you change for the project ID and the project number. You can get the project number from the CLI, and we use the project number. Yeah, we have a lot of them, and here's the unique project number. So we use this to build unique names for the GCF or a unique name for the GCS bucket that the modules create. And this is because the The way GCS works is that all the buckets from all GCP users are in a single namespace. So you need to make sure that your bucket has a unique, globally unique name. So we're using the project number for that, and a DNS name that could be hosted on Google Cloud or any other provider. And we will use this to also to configure a FQDN to access Flyte and the GCP region. Also an email. This one is important because as you will see, these modules also configure SSL. So the modules use Let's Encrypt and Cert Manager to automatically create a signed certificate for the ingress. And this particular email address will be used by Let's Encrypt to send you warnings when a certificate is about to expire, etc. So you should consider changing this. And also by default, the projects and domains that are enabled by default in the implementation. So I will leave it as is. So these are the main things you need to change. And also you need to go to Terraform, to the Terraform module. And here in the backend, you need to specify the bucket name that you will use for Terraform state. Remember the one that I just described here is this one, right? You just need to specify the name. All right. If it's the first time you run this, the first thing you will do will be a Terraform init, right? And then a Terraform plan. Probably I will run a Terraform plan. I already performed the init, so I won't do it again, but probably we can do it just for the sake of demonstration. Nothing changed, so everything was already installed. All the providers were already installed, but if it's your first time, it will install all the dependencies. Then I will run a plan. So this is kind of a dry run. It will inform you, hey, these are the plan changes. I won't do anything. So I'm just informing you, these are the changes I will do on your environment, right? So it's also a good way to catch probably syntax errors if in the process of customizing your locals file, probably there's I don't know, missing colon or etc., something like that. It will be captured here. So for now, it's all green. It's cool. So we will go straight to Terraform. Terraform apply. It will again compare the state. I mean, the current state of the environment versus the intended state in the modules, and yeah, it needs to deploy everything. 59 resources to create. So I will say yes. It usually takes from 15 to 20 minutes if no errors. So in the meantime, I will keep describing the modules. So first one in the list is the GKE module. This is how the end result looks like. It will deploy a GKE cluster using this table release channel. So probably you will see here a Kubernetes version that is 3 to 6 months years old. To 6 months old. Right now it's 1.27, which is fairly recent. I mean, 1.29 was released yesterday, so this is pretty cool. And also it will deploy the node pools all automatically. Let me give you a look at the code. So here is, again, it will use the name prefix to build the name of the cluster. So it will be, for example, in this case, Flyte-GCP will be the name of the GKE cluster. And yeah, the release channel is stable. It will be a regional type of deployment. And the node pools by default in this reference implementation use this type of instance type. I think this is 4 vCPUs and 16 gigs of RAM, if I'm not wrong. And but you can change this. You can adapt this to your environment. This is a compact, let's say a compact or mid-sized instance type that can run the majority of the basic workflows without issues. But if you need, if you have heavier workloads, probably you will need to change the machine type or the instance type, right? Cool. Yeah, I think it's pretty straightforward. Next up, the GCS module. This one will create an additional bucket, and this bucket by default we use for storing the outputs from tasks, from executions, and also to store metadata. For example, if you eventually enable caching, uh, it will all be stored in that bucket. Right now, we're working on enabling Flyte Core, the Flyte Core Helm chart, and I make a parenthesis here. There are two main Helm charts to deploy Flyte. Flyte binary that ships everything in a single binary, and Flyte Core it's more designed for multi-Kubernetes clusters environments where you will see uh, multiple pods for the different components. You will see I don't know, two pods for Flyte admin, pods for Flyte propeller, etc. And Flyte binary, you will see a single pod for everything. And in Flyte core, there's a current limitation to specify a separate bucket for metadata and for storing task outputs. That's about to change, but that's the current status. So that's why this reference implementation, which uses Flyte core, will only deploy a single bucket, right? But that will change soon. But even so, I mean, specifying an additional bucket is optional. And we are aware that having a bucket just created and doing nothing costs money. So these modules only create a single bucket and configure Flyte to store everything there. Okay. Let me see. Yeah, it's making progress, creating the database. Now the ingress module, this is interesting because, well, we first created the Flyte and Nginx namespaces. I know that a Helm chart or a Helm install command can also automatically create the namespace, but for the ingress module, we are not using Helm charts. The first step is deploying the Nginx controller. I will show you the code in a bit. Remember that when you define an ingress resource, this is only aspirational goal because you need a third-party controller to actually reconcile that configuration into an actual ingress resource. There are multiple ingress controllers out there available. In this case, we're using Nginx. We are aware that many GCP users require the identity-aware proxy and the native GC controller to manage this type of connection. There's already support in Flyte for the IAP, but it's not yet available as an automated Terraform module. There's an issue for that, and if you want to help with this, that will be awesome. It's in the in the roadmap to have also an additional reference implementation that uses the IAP, the identity aware proxy. But for now, it's the Nginx controller. Next step is that the modules will install the Cert Manager CRDs, and this is important because I mean it's kind of explained in the code. There's a link for the Cert Manager docs, but in summary, there's a limitation on how Helm handles CRDs. So the recommended approach for production environments is that the Cert Manager CRDs should be installed just using a manifest. And that's what you will see in the code. Then Cert Manager controller is deployed, and then a Cert Manager issuer is created. So this is all the structure to ensure that whenever Flyte is created or Flyte is deployed also by the modules, automatically the ingress is enabled, and there will be a controller available to A, um, create an ingress resource, and B, create a signed certificate, SSL certificate, and associated with the ingress. So whenever you perform a connection via the UI or the CLI, it follows an SSL. It's an SSL tunnel, let's say, and the SSL connection is terminated in the ingress. It doesn't include authentication, and that's an important thing to mention. Right now, it's a recommendation in docs. The next thing you should do is to configure auth with your identity provider of choice. One thing we want to do, and there's an issue for that, is to also add automated authentication to these modules using, I will say, using key clock as IDP, because it's kind of the easiest to embed into a cluster, make it a workload, and use it as an IDP. But for now, it will handle all the SSL configuration for you, right? So let me show you the code right away. This is what I mentioned: namespaces, the Nginx controller. It downloads and processes the manifest for the server manager CRDs and install the CRDs. This secret is used by server manager to configure TLS, install server manager, and an issuer. Right? This issuer is running in the Flyte namespace. And here you can see that it's created with the email that you provide in the local file. Cool. Okay. Yeah, it's live. It's not finished, but it's creating the Nginx controller or deploying the Nginx controller as we speak. Cool. Next up, this one is pretty interesting. I spent a bunch of time with this, and I really want to give a shout out to multiple community members, including Fabio Gratz, member of the steering committee of Flyte, for his support on this, on refactoring the IAM module to make it more aligned with Google's security recommendations and kind of making it more granular. So this is the overall structure. Again, it uses the recommended approach of for enabling GKE workloads to access GCP resources. In this case, it's using workload identity. So you will have a number of pods here running on GKE, be it Flyte itself, the Flyte control plane, or your task executions. So there will be Kubernetes service accounts for this type of workloads. There are service accounts for the control plane, and there's service accounts for the task executions. They will be automatically annotated with a specific Google service account. So the Kubernetes service account will impersonate or will use the Google service account also with a custom role with just specific permissions. And this combination plus the workload identity user role will enable the GKE workloads to get an access token and be able to consume GCP resources securely, right? So in the past, and I still see this eventually even in other clouds, users, for example, using the Kubernetes node IAM role to do everything. That's not good, because that gives broad permissions for anything running in a node. This is as granular as possible at the pod level. It will give you this level of permissions. It's all automated. You don't need to do anything. So here you can see the IAM role. So the first thing that it does, kind of the process explained there, but it will create this Google service accounts for the different components. This is also in line with Google's recommendation of making the permissions as tight as possible or as specific as possible. So we have a service account for Flyte admin, propeller, scheduler, data catalog, and the workers. What we mean here by Flyte workers are the when you execute a workflow in Flyte, every task will be a pod, and those pods will use a service account, and in turn, that service account will impersonate that. Well, the pods will use a Kubernetes service account, and uh, and that service account will be associated with a Google service account, and so on and so forth. Right. So, first step is to configure what will be the Google service account. There's a special one. This one, it's only needed if you will be using Artifact Registry as your repo for container images. If you don't need it, you can just remove it. But it's there because many times users, the next thing they do is to try to push custom images to Artifact Registry. So it will do the things. The first thing is that it will create a service account with write permissions. Right now, it's only created in service account. And also, it will enable the workers to have read permissions to be able to pull images. I will cover this by the end of the session. Next piece is to create the custom roles. So here you can see that the permissions are as specific as possible. We are not configuring admins, storage admins, nothing like that. So Flyte admin, just the stuff that it needs in the blob storage, propeller, the scheduler, data catalog, and the workers, right? And we are basically assigning these permissions to each custom role. Then we perform an IAM binding at the project level, and we bind together the custom role we just created with the corresponding Google service account. So this is what we have here. Custom role with the service account, right? It's right there. And this one here, it's what I was mentioning. It binds the Artifact Registry service account that we just created with a role. This is a default role. It's not a custom one, a default role to be able to push images to Artifact Registry. Next step in the overall process is to do now a binding at the service account level. So this is where you bind the actual Kubernetes service account. See, it's mentioned in the namespace, the Flyte namespace, and the Flyte admin service account, Kubernetes service account, and binding this to a Google service account with the only required role to be workload identity user, basically giving it access to impersonate a Google service account with a specific set of permissions, right? And the next thing we do is to do the same, but for the workers, the process is a bit different because in every namespace, by default, you will have 3 namespaces to run workloads. The Flyte snacks, let me show you. The Flyte snacks dash development, Flyte snacks staging, Flyte snacks production will be 3 namespaces, and each of them will have a default service account that by default will be used by the bots to do everything. So we needed a different structure to go recursively throughout all the namespaces to configure this binding and enable them to be workload identity users for the Flyte workers service account, right? Cool. So that's the IAM portion, and it's done. I haven't even finished the description, and the process is already complete. Cool. Great. Right on time. How to use it. So once the modules are done running, the only output you will see is this, the GKE cluster name. And the reason for this is that we will use this to configure kubectl to be able to connect to the Kubernetes cluster from the CLI. You can do the same from the Google console, but I wanted to avoid any kind of context switching. So we will do most of the stuff here in the CLI. So the next piece, according to docs, will be to, let me show you here, will be to do the following, and is basically to connect, I will do the cloud container, clusters get credentials, the name of your cluster, in this case, Flyte dash GCP, it's here, this name, the region, and the project name, and it will create a new entry in the kubeconfig, in your local kubeconfig file, and it will automatically change the context there. So you can see here that, for example, if I get nodes, this is running on VK, right? It was deployed 7 minutes ago. So this is your new environment. So we need the CLI because we need to know what was the actual address, IP address configured for the ingress. The fact that there's an address configured means that the Nginx controller was able to do its job, reconciling a request and actually fulfilling this and configure an ingress resource. So the instructions from the README is to go to your DNS provider and make sure that your host or your FQN now points to this specific IP. I have my DNS on Route 53, so I guess that makes me a multi-cloud user. But I'll go here. It's pretty simple. It's an A. There you go. It's a type A record, so it's pointing to an IP address. In this case, this one. Cool. It takes some time to propagate. In the meantime, what I will do, this is all in the README. What I will do is to make sure that my local config file points to my FQDN, to my domain name or my DNS name. Why is that? Because every time you use the Flyte CLI, it will query the configuration here, and that's what it will use to try to connect to a Flyte cluster. So right now, yeah, here I have here a bunch of things. So every time I need to move between environments, I uncomment stuff. So I have this endpoint. It will be flyte.demo.run. You can use the host you need, where you will define that host here, right? The DNS domain. By default, the FQDN will be formed by the application, but whatever you use here in application, dot your DNS domain. So you can change this accordingly. I'm using this here. We'll make sure that this is insecure false. So it will force the CLI to use an SSL connection. I will say changes here, right? So if I do something like flightctl get projects, it's great because the certificate is not trusted. Yeah, it takes some time. Remember that we there's a module that I didn't cover, is the Flyte module. This module, thank you. Yeah, this module actually installs Flyte for you. So if you take a look here, get pods in the Flyte namespace, everything is already installed for you. I mean, Flyte admin, propeller, console, everything is there and running. And we didn't touch Helm charts or whatever. So this module takes the outputs from all the previous process in your Terraform execution, and it uses that information to actually install the Flyte core chart in the namespace, in the Flyte namespace, right? So everything is installed. But the thing with that is that it uses this file, and if you go to the ingress portion, right, everything is automated. It's configured to use TLS. right? But at the first moment, it deployed everything, configured everything, but the actual Flyte.union demo that run over your domain name wasn't actually resolving because we just created the A, or updated the A record, right? So for Server Manager to be able to actually issue a certificate, the DNS record needs to resolve, or the host needs to resolve, and that takes some time. I've seen anything from minutes to hours, multiple hours for this to propagate. It depends on how your DNS configuration works. But eventually we'll have here a certificate. Let me see. Seems like it's ready, but let me try again. Otherwise, we can try with no. We can try with let me see. We can try with insecure true. In the meantime, just to make sure that connection. What is happening here? That's not cool. Um, okay, let me see. With this finish. Okay. Mm, there you go. Yeah, it seems to be pointing in the right direction. One last thing. Yeah, I mean, we can use this and use this as a last resort. And otherwise, I'll be, yeah, there you go. So what I did is I instructed, yes, it's an SSL connection, but you cannot yet verify that this is that the certificate is trusted, right? Because right now it's using the default. This is default for every Cert Manager implementation. It will use this default certificate 1 to 0. But yeah, it's working. The projects are there. If you go to the flyte.uniondemo.run/console, it should be there, but with a warning on the security side. Yeah, certificate is not there yet, and I'm not sure why it's not letting me. Oh yeah, it's just yes. Yeah, this is actually interesting. But yeah, should be there, visible for you. There are ways to troubleshoot this uh, certificate request. It's approved, but it's not ready, and probably the reason is because the actual um, DNS name is not resolvable just yet, right? Let's see here. Um, there we go. Yeah, it's pending. Um, yeah, it must typically it's due to the reason that I just mentioned. Is I mean the request is right, but it's correct, but it's pending DNS resolution. Takes some time. Right, but that's a kind of a dependency, not exactly a Flyte thing. At least Flyte is alive and running, and try to use different browser just to make sure that I can override this. If I can show details, basic, yeah, basic, no matter what. So it's there, right? Cool. So I can start running workloads right away. So if I do a PyFlight run, I need to add dash remote to make sure that this runs in the remote cluster, and I will run the example workflow. So it's a good way of testing everything. Yeah, this is a warning. Certificate verification is strongly advised, but it's pointing me to the console now. Now you can see it's running, and hopefully, eventually, it will run successfully. Right. The next thing we can do here, or probably the next thing you will be trying to do, is try to use a custom image, as I mentioned. So the README provides the instructions. Let me take this out. The instructions for using artifact registry. But in summary, we're using a process that is documented by Google. We're not reinventing the wheel in this case. So right here, what we have, let me go back to the diagrams and probably show this here. So we have two types of operations here, a push and a pull, right? For the push, we have a Google service account that has the registered writer option, as I show in the IAM module. Let me point you here. There you go. So we have this artifact registry writer, and the writer has the actual permissions. Where are you? Yeah, there you go. The actual permissions to eventually push images to the repo. Your particular username will use the service account, will impersonate the service account to get an access token. And with this, you will be able to generate an image pull secret, add it to the default service Kubernetes service account, and in that way, and plus the artifact registry reader role that was already assigned to the Flyte workers, it will enable the Flyte pods to pull the images, right? So it's a two-step operations. First, for the push, you as a user, or if it's a CI system that needs to consume this programmatically, it will be the same. It will use this role, your service account, the artifact registry writer, to be able to push, and your pods will use this role to be able to pull, right? So the process is covered here to actually make use of this. In the meantime, let me see. Yeah, it's all green. At least it works, and you can see here just testing everything. The outputs were stored in the Flyte GCP data Google storage bucket that the modules created, right? So it's all there. And you can see here that it's using the default service account in each namespace. You don't need to know Kubernetes for this. This is just informational, right? So the next piece, I'd like to have a better way to do this, and there are ways to automate part of this process. But for now, I'm leveraging what's documented by Google Cloud and how to connect to artifact registry. So that's what I'll do here. The next step will be, here's the reference to docs, but the first step here will be to create an actual key. So this is the cloud. Okay. Okay. Service account keys. So we'll create first all that is required for the writer role, because that's the first step in the operation to write. So we will use here that GCP registry writer. That's the service account or Google service account we're using. And we will store this as GCP artifact writer key, right? So that's the first piece. You can see here that it created this key. Cool. The next step will be to actually activate the service account, right? So this is the impersonation kind of operation. where you will provide your key file, the one that was just created, and the GSA, the Google Service Account you will impersonate from your G-Cloud session or from a CI system. Right, so that's the next piece. Cool, activated service account. So in that context, the next piece will be to actually authenticate to your repo, cloud out login. Sorry, print access token, Docker login, etc. And the only thing you need to change here is the location or the region for your registry. I will show you here before running this that this is where my artifact registry. I have it configured in my project. It's configuring the same project where I'm running this. And there it is. It's a Docker type of registry, and it's there, right? So we'll log in, and the result should be a login succeed, something like that. Yeah, there you go. Login succeeded. So your G-Cloud session is authenticated. The next piece is that you need to generate an image pool secret to be able to actually configure the pods to pull images, right? This is all covered here. We will then again create a keys, but in this case for the workers. We don't have a separate Google Service account for reading or for pulling images. We're using the one assigned for all the Flyte workers to make it even more direct. Artifact reader. Yeah, I need to do this. Remember that I use a context with a service account, and that now that I'm using a different one, so I need to kind of reset the identity I'm using to perform this operation. This one, creating the keys. Cool. It created the key. The next step, sorry for that. The next step will be to create a Kubernetes secret. This is the particular step that I'd like to automate, but it's heavily opinionated if we add this to the automation. There's a bunch of content there, or that's what I see so far, probably. In the near future, I am proved to be wrong, but the reason for this is that this secret needs to be available in each and every project domain namespace that you have in your environment. If you create a new project, right now we only have one project. If you create more projects, you will have 3 additional namespaces, so 3 additional default service accounts. There are ways to automate this from Flyte using cluster resource templates, but for now, for the sake of this session, I'm using just what is documented by GCP to make it work for a single namespace, right? There's a note there in the docs that says, yeah, kind of you need to do this for every namespace, but we want to automate this. So we will create a secret kubectl create secret Docker registry. We will call it artifact registry, right? And it will ask for the Docker server, is the location of your repo. The email is basically a service account, the email address for the service account that you will be using. The username is JSON key. Docker password is the actual key that you just created. I think the file name is different. And the namespace, because as you probably know, secrets are namespace resources in Kubernetes. So I'm doing this specifically for the default Flyte Snacks development namespace, right? So I'm just creating the secret. The secret is there. So the next thing I need to do, it's not great. I don't love this, but it's what it is right now. You need to edit You need to edit the default service account and specify image pool secrets. And then you need to say this name is act artifact registry, the one we just created. And if it's all right, to edit without problems. And now you can run workloads that use a custom image. So I will use a, a workflow. It's very similar to the Hello World workflow. The only difference is that it uses a custom image. I had this. Um, this one, and we use image spec, which is a feature that is particular to Flyte, where you don't need to write Docker files because it's not especially convenient. So you just define here the configuration you need for your custom image, and it uses a plugin called MVD, and it will build the Docker image for you. It's really cool. So I will change the name here just to trigger a new build, make sure that at least a new layer will be pushed. And yeah, let me Flyte run, but just remote image spec is the same workflow, the training workflow that we just used. There you go. So yeah, my color scheme for my CLI it's not great, but I hope that you see here something. But probably by the end, yeah, most of the layers are cached, which is perfectly normal, but there will be at least um, one new layer here. Pendulum, it's because we instruct the code to add pendulum to custom image as a package. So it's building wheels, and eventually, I mean, right now, it could still fail if we don't have the correct permissions. There's one point where it will finally push the image, and that's where all this theory that I showed will come to reality. Pushing layers. There you go. Pushing layers, and it's done. And it's done. So if it's done, I should see something here, something new. Let me refresh this. There you go. Flyte School. There's a new image there. Cool. Okay. So it asked me to go to the console. Flyte Snacks development, Flyte demo, Flyte Snacks development. There you go. It's running. Yep. It's running without problems. It uses a custom image push to artifact registry. That's great. All right. I think that so far that's it in terms of content. Again, for the SSL thing, just remain patient. Uh, if you experience a long issue with this, just hit us up. Probably that's the call to action here. Join the Slack community and head over to the Flyte on GCP channel. We usually hang on there, available to answer questions. Um, every time we've seen this kind of behavior with SSL is DNS propagation that hasn't finished. You don't need to really do anything at this point. And you can see that even temporarily, you can use it without SSL verification. And if you like what you see, please go to the Flyte repo and give it a GitHub star. Doesn't take much time, but it's really meaningful to us. You can find Flyte on LinkedIn as that Flyte. There are multiple Flytes. There's even a band called Flyte, but that is the right Flyte in on LinkedIn, and Flyte.org in the Elon Musk social media. I hope you enjoyed this. I hope it's useful for some of you. And yeah, thank you for watching.